Year 13, right. So in the last video, I introduced the four main sort of characteristics of transition metals, just to repeat what they were. Variable oxidation states, colour, which is the exciting part, catalytic properties, very, very important, and the ability to form complex ions. Now, it's the complex ions things that's probably very new to you, and therefore I need to spend a bit more time talking about complex ions and different types of complex ions. And I'm just going to do a very simple one to start with. We've already come across this guy. This is the hexaaquo copper 2 ion, always blue. It doesn't really matter at all what this is. It's actually copper sulfate, but it could be copper nitrate, it could be copper chloride. They would all look the same, they'd all look blue. Why do they all look blue? Because of the presence of this chap here that we talked about before. The copper 2+ ion, it's got quite high charge density because it's very small, pulls in 6 waters around it. These are called ligands because they have a lone pair that can form a dative covalent bond to the central metal cation. Notice this is still 2+. I didn't explain this in the last video. The waters are neutral, right? So these are all neutral, so therefore this is still 2+. Okay, we're going to do a little experiment here, and we're going to look at a different complex ion. So what I've got is here some conc-HCl. Now, you probably know this as having lots of H+ ions in. We're actually going to utilise the fact this has got lots of chloride ions as well, because obviously it dissociates completely. So we've got lots of H+ ions in here, and we've got lots of Cl- ions in here. Now, what we're going to try and do is we're going to try and make a new complex ion. So I'm going to steam a little bit in the air, and I'm going to pour this. You can probably see there's a colour change going on, and it's turned to green. So what's happened there? Is this some sort of redox reaction we've got going on here? No. All we've got going on here is a change of ligand. This is called ligand substitution. Let me explain on the board here what's happened. We started with our hexaaquo copper 2 ion, which I've drawn out a few again here. And we've added lots and lots of chloride ions. The conc-HCl has lots of chloride ions because it's a strong acid, so it completely dissociates. Notice I'm not bothering with the H+, I'm just talking about the chloride ions here. And what we've done is we've formed a new complex ion. Now, the copper 2+ is now attached to 4 chloride ions. So there are 4 Cl- surrounding it, and that's why the overall charge is now 2-. Notice it has a different geometry, it's tetrahedral. Well, why is it tetrahedral? Why is it not octahedral? Why can't we get 6 chloride ions around it, and why can't this be 4 ions? Chloride ion is a negative ion. It's therefore quite large. Water molecules are neutral and are quite small. It's just the size of the chloride ion is too big. So the maximum we can get around any transition metal for the tetrachlorate, in this case it's the cuprate 2 ion, but all transition metals can do this. They can form a tetrachloro, whatever this metal is, 8 something oxidation number ion, and they all have different colours. In this case, we've seen the conversion. This was blue, and this is turned to a sort of green colour. In fact, you often see it written down as yellowy green, and I think if I add lots more conc-HCl, I might be able to get it to go more yellowy green. Let's see if I can. I think I'm running out. No, I'm only going to be able to get it to go to green. It's not going any more than that. But I can easily convert this back to the hexaaquo ion. How can I do that? Well, just add loads of water. So if I now go over here to the tap, look, and I add water, bingo. All I've done is I've pushed the equilibrium. If we imagine this reaction now as an equilibrium, it's gone back to being blue, and all I've done is I've added loads of water and I've pushed the equilibrium back this way. So now the complex ion you can see is once again the hexaaquo copper 2 ion. I could, of course, if I had enough, and I don't because I'm running out, but if I had enough, I could add more conc-HCl. Oh, you probably saw it when it's trying to go green, but there's so much water in there now that unfortunately I can't get to go back to being green again. Okay, simple introduction to 2 different geometries of complex ions, octahedral and tetrahedral, and looking at the fact that you have different ligands, in this case the chloride ion.